This video is going to cover product rule and quotient rule. So they're two different ways of differentiating, and it's dependent on what the original function looks like. So the product rule is when two functions are multiplied together, and we have to differentiate that using the product rule. And then the quotient rule is used when we've got one function divided by another. So we'll cover product rule first. So the best way to remember the product and quotient rule is by saying what I've got in quotations here. So the product rule is the derivative of the first times the second plus the derivative of the second times the first. And then what I've done is I've also written that out, and I'm just putting a box around it now, how it would appear on a formula sheet. So if y equals f of x times g of x, then the derivative is f prime x times g of x plus g prime x times f of x. So it's just easier sometimes to remember that it's the derivative of the first times the second plus the derivative of the second times the first. So we'll do a couple of examples now. So you can see here we've got y equals 5x take 1 times 2x plus 3. So they mean multiply because there's two brackets. So the product rule is the derivative of the first times the second. So what we'll do first is we'll write down dy by dx equals, so the derivative of the first, so the first function is 5x take 1. The derivative of that is 5 multiplied by the second, so we've got times 2x plus 3, plus the derivative of the second, which is 2, times the first, which is 5x take 1. So we've got here 5 brackets 2x plus 3, close bracket, plus 2 brackets 5x take 1, close brackets. So then we can expand both of these. So we've got 10x plus 15 plus 10x take 2. So we end up with 20x plus 13 as our expanded answer. In some questions, you don't always have to expand the product rule to write down to how I've done that with the 20x plus 13. Sometimes it's appropriate just to show that you have actually used the product rule. So the first line of working might be sufficient. Just have a look at mark allocations when you're doing those. Second one, we've got y equals 3x take 5 times x squared plus 5x take 7. So we write down dy by dx. Now we're doing the derivative of the first, which is just 3, times the second, which is 3, times x squared plus 5x take 7. And then we add on the derivative of the second, which is 2x plus 5, multiplied by the first, which is 3x take away 5. And again, we can expand that if necessary. Otherwise, that is showing use of the chain rule. We will expand it just so you've got that expansion knowledge in here as well. So we've got 3x squared plus 15x take 21 plus 6x squared plus 15x take 10x, which is 5x, take away 25. And then again, we can collect those like terms. So we would end up with 9x squared plus 20x take away 46. Again, if it just said show the chain rule to differentiate this particular equation and it was only worth 2 marks, then you could just leave it in the first line of working. But you would not be marked wrong if you had simplified it. Last one is find the equation of the tangent to y equals 3x take 5 times x plus 2 at the point 2, 4. So this one's just an equation of a tangent problem, because even though that's covered in normal differentiation, we need to make sure that we can still do that in product rule and quotient rule. The whole process is the same. It's only the way you differentiate the original function changes. So again, we do dy by dx. So derivative of the first is 3 times the second, which is x plus 2, plus the derivative of the second, which is just 1, times the first. So you don't always have to write the 1. I purely write it just so I know that I've actually written the derivative there. And then we can expand this. So 3x plus 6 plus 3x, take 5. So we would end up with 6x plus 1 as our gradient formula. Now it says at the point 2, 4, so we need to find, when it's asking for the equation of the tangent, we need to find the gradient at that point. So when x equals 2, the gradient, dy by dx, is equal to 6 times 2, which is 12, plus 1, which is 13. So then, so far, we know y equals 13x plus c, and then, of course, to find c, we need to sub in a point that's on that line, and we know that 2, 4 is on that line. So we would have 4 equals 13 times 2 plus c, which makes c negative 22. Therefore, the equation of the tangent is y equals 13x, take away 22. So again, just with product rule, it's the derivative of the first times the second plus the derivative of the second times the first. Moving on to quotient rule. So again, there is an easy way to remember it just using the words, and the way we do that is bottom D top minus top D bottom all over the bottom squared. So when I say bottom D top, that means it's the bottom function multiplied by the derivative of the top function. Take away the top function multiplied by the derivative of the bottom function, and then it's all over the bottom function squared. And again, I'll put it in a box. I've put it in how it would be written on a formula sheet using f of x and g of x. So if y equals f of x divided by g of x, then dy by dx is equal to g of x times f prime x minus f of x times g prime x over g of x squared. So example 1, differentiate y equals 3x take 5 divided by 5x take away 1. So we have to first write out dy by dx, and it's bottom D top. So the derivative of the top is 3 multiplied by the bottom. Take away the derivative of the bottom multiplied by the top, all over the bottom squared. Now, most of the time with quotient rule, if you are going to simplify, you only need to simplify the numerator. So what we're going to do is we'll just expand that. So we end up with 15x take 21, take 15x plus 25, remembering that negative 5 times negative 5 gives us positive 25, all over 5x take 7 all squared. So we end up with, I'm just going to go up to the top here to write the answer. 15x take 15x is 0. Negative 21 plus 25 is 4. So we've got dy by dx equals 4 over 5x take 7 all squared. And that's our answer for the first one. So again, with quotient rule, you just need to show that you can do the differentiation of the numerator, and then also making sure you're squaring that denominator to get the full derivative. And again, most of the time you are only asked to simplify the numerator, so you can just do that. And the second example, which is the last one for this video, so we've got y equals 3x divided by x squared plus 3. So we do the derivative of the top times the bottom, so 3 times x squared plus 3. Take away the derivative of the bottom, which is 2x, times the top, which is 3x, all over x squared plus 3 all squared. And again, if we simplify that numerator, we get 3x squared plus 9, take 6x squared, all over x squared plus 3 all squared. And then again, we just collect our like terms. So we would end up with negative 3x squared plus 9 all over x squared plus 3 all squared. And again, you could factor out the 3 at the top and then simplify that way, but that would be enough for, say, a 3-mark question. So hopefully that has given you a bit of insight into how to do the product rule and the quotient rule. Again, they are just two new rules to do with differentiation, depending on the type of function that you're given to differentiate. So if it's just a normal polynomial, you just use your normal differentiation techniques. But then if it's a function multiplied by another function, it's the product rule. And then if it's a function divided by another function, then we use the quotient rule.